All right, we are on 7.03 for pre-calc today. We're talking about partial fraction decomposition, which can be a really tricky topic. So first of all, a couple little things here. Partial fraction decomposition is used when the denominator's exponent is greater than the numerator's exponent. If the numerator's exponent is larger, so if you have a higher exponent on the top, then you would need to use long division first. We cannot simply split a fraction. So let me show you what I mean by that. So if I took x minus 2 over, say, x minus 4 times x plus 5, I cannot just say, so that is not equal to saying x, so taking the x here, over x minus 4, so part of my denominator, plus the negative 2 over the x plus 5. Those are not equal. It does not work out, and I'll show you why it doesn't work in just a moment here. So what we'll do instead is we have to use linear systems to solve for a and b if, let me show you where a and b is. So if we take that x minus 2 over x minus 4 times the quantity x plus 5, I can split that into two separate fractions. So the first fraction will have the x minus 4, and the second fraction would have the x plus 5. But I can't just take the x and the negative 2 like I did up here. So instead, we'd have to solve for what those numerators would be so that it would be equal to x minus 2 over the product of x minus 4 and x plus 5. So that's how we're going to decompose these fractions. First, before we start our decomposition, I want to show what we just said is not true. So if I take 5 minus 2 over 4 times 3, is that equal to taking the 5 over the 4 minus the 2 over the 3? So let's see if that actually is true. So we take 5 minus 2, that's equal to 3, and 4 times 3 is equal to 12. So that tells me that this right here is 3 over 12, or I can reduce that to 1/4. Now let's take a look at this side over here. So over here we have 5 over 4 minus 2 over 3. So we want to know, if I do it this way, will it give me 1/4 or 3/12? So in order to do this, I need a common denominator. So with 4 and 3, my common denominator would be 12. So I'm going to multiply this one by 3 over 3, and this fraction by 4 over 4. And the top, if I multiply across the top, I get 15 over 12. 2 times 4 is 8 over 12, and then 15 minus 8 would give me 7 over 12. So this side of the equation is 7 over 12. This side of the equation is 1/4 or 3 over 12. So those are not equal to each other. 7 over 12 does not equal 3 over 12, which is why mathematically it doesn't work. We can't just split the fraction like that, which is why we have something called partial fraction decomposition. So for number 2, we're going to start off really basic, and these are going to get quite a bit more challenging, but I just want you guys to get the idea of how the setup's going to go. So we're going to write the form of the partial fraction decomposition of each rational expression. I don't want you to solve on these ones, and you'll see some in your textbook also say not to solve. We just want to practice setting it up at this point. All right, so for letter A, how we're going to do this is first we're going to factor the denominator. So let's see, we've got 7 in the top, and then I have a GCF of x in the denominator, leaving me with x minus 14. So really important to first factor your denominator. Next, we want to split the denominator. So just like we did up here, where we split it into x minus 4 and x plus 5, right here in this example inside the dotted box, we're going to do the same thing here. So you have to include everything, and you have to include them up to their highest exponent, which I'll explain more in a minute. So one of my denominators has to be an x, and the other is going to have to be x minus 14. In my numerators, I'm going to ignore the 7s there, and I'm just going to put an a and a b. And if I had another fraction, it would be a c, and another d. So we're just saying we don't know what's up there, and we'd have to solve for that. We're not going to solve for it today, or we're going to solve for it today, but not quite yet. For letter B, we're going to start with the same thing. So pause the video here and factor out your GCF in the denominator. So here you should have factored out an x squared, leaving you with x minus 10. Now, here's where it gets a little trickier. You must include all the factors at each increasing exponent. Let me write that. So you must include all factors at each increasing exponent. So what I mean by that is here we have an x squared right here. So not only do I need to include x squared, but I have to include everything that comes before that. So we're going to include an x in our denominator, then also an x squared. If this had been x to the third, we'd do x squared, and then x to the third as well. So whatever your exponent is, you go up to that starting at 1. And then I also have to include this x minus 10. The x minus 10 does not need to be in parentheses. I put it in there for some reason, but you don't have to have parentheses there. Now, since I have 3 different fractions, I'm just going to use A, B, and C. And that would be my setup. And I'd have to solve the system of equations for A, B, and C, which we'll do in just a minute. Let's do one more of just setting up and not solving. And then we'll go on to solving, which are pretty lengthy problems. All right, so again, we're ignoring the numerator. We're really just looking at that denominator of x plus 2 raised to the 4th power. And that one's already in factored form, so we're just going to include every exponent starting at 1 up until an exponent of 4, which is what's in there. So starting at 1 means I'm going to do x plus 2 to the 1st power plus x plus 2 to the 2nd power plus x plus 2 to the 3rd power plus x plus 2 to the 4th power. And then on the top, we're just going to do A, B, C, and D. So this is just the form we would use. That's how we would start the problem. And then we would have to solve for A, B, C, and D. And that would tell us how we could separate this fraction using addition, separate it into its different parts. All right, so let's start on the next one. So these do take up a lot of space. There's not a lot to write, so easy enough to just write out your original, but there's a lot of work that we're going to be showing here. First step is to factor your denominator if it needs to. If there's nothing to factor, then you're good to go. So I've got 2x squared plus 3x minus 2 in my denominator. So pause the video here and go ahead and factor that. All right, so you want to use P's and C's on this one. So my P, hopefully you already did this on your own, is -4, C is 3, so I'll go pretty quickly. 2x squared blank x minus 2. I need 2 numbers that multiply to -4 and add to 3. That's going to be +4 and -1. Group my first 2, group my last 2. Factor out a 2x, leaving me with x plus 2. Factor out, since the first number is negative in the parentheses, factor out a -1, leaving me with x plus 2. Parentheses are the same. Pull that out, write it only once, and then my leftovers, which are 2x minus 1. Okay, so that's my denominator factored. So now I have 5x minus 10 over 2x minus 1 times x plus 2. All right. Now we have to do what we did before and set up our equation. So we're going to take 5x minus 10 equals our factor denominator there, or 2x squared plus 3x minus 2, equals. Now over here, I'm going to include all of my factors. Now none of them have an exponent higher than 1, so I just need to include each of my individual factors, which is 2x minus 1 and x plus 2. And then on top, I put my a and my b. So first step, all we've done is exactly what we did on that last page of just setting it up. Now we need to solve for a and b. So to solve for a and b, we want to clear out our fractions. So 2 was our setup. And then 3, you want to clear out the fraction. So just like we cleared them out when we solved equations last year in Algebra 2, you want to do the same thing. So you want to find your LCD, which in this case, our LCD, oh, I thought I changed. LCD is 2x minus 1, looking at all of your denominators, and an x plus 2. So I'm going to multiply everything through by that. Oh, here's some more colors. Let's do purple. So I'm going to take this, multiply this, 2x minus 1 over x plus 2 over 1. So everything gets multiplied by my LCD over 1. And then I'm going to multiply this one here by 2x minus 1 and x plus 2. And then the last one by 2x minus 1 and x plus 2 over 1 is what that will look like. All right. Next, we want to clear out. Actually, you know what? I'm going to rewrite this for you guys because it's a little squished up there. And since it's our first one, make it nice and neat for you. So that's my LCD over 1. I'll put in purple, and then I'll put in pink the original. So 5x minus 10 over 2x minus 1. So I'm just rewriting what I just wrote up there. So then I have a over 2x minus 1. I'll switch to purple, times my LCD over 1. So that's 2x minus 1 times x plus 2, all over 1. Back to pink, plus b over x plus 2. And then switch back to purple to write my LCD over 1 again. So every single term gets multiplied by your LCD over 1. And as you get more comfortable with these, then you might want to do it like I had it at first, where I just added it on so you don't have to rewrite it so many times. But for today, I think it might be more helpful to look at this. Okay, so now we're going to cross reduce. So I've got a 2x minus 1 in the denominator and in the numerator, and I have an x plus 2. So everything canceled out here. Here I have a 2x minus 1, cancels with my 2x minus 1, and my x plus 2 with my x plus 2. Do a quick check now that every denominator is either a 1 or canceled out. So we wanted to clear out all of our fractions. So 1, canceled out, canceled out, canceled out, 1, canceled out, 1. Now let's write what we have left. So now I have just 5x minus 10 equals a times x plus 2 plus b times 2x minus 1. All right, so now we want to, we need to solve for a and b. So what I want to try to do here eventually is I want to get this right-hand side to kind of match up with this left-hand side over here. So in order to do that, I need to start by distributing my a into my parentheses and my b, and so I can kind of combine like terms. So I'm going to distribute the a and the b into their set of parentheses. So I get ax plus 2a plus 2bx minus b. Notice over here on the left that you have the first term, the 5x, has an x attached to it, and the second term is just a constant. I want to try to group everything on the right side now that has an x together. So I have ax and I have 2bx. So especially for this first one, I'm going to just rewrite those next to each other. And then write my plus 2a minus b. So everything in purple has an x, everything in pink does not have an x, it's just a constant. So now what I want to do is I'm going to look at just the two terms that have an x, and I'm going to factor out an x from those two. So I take out an x, which leaves me with a plus 2b. So I'm only looking at those purple terms. And then I still have my pink terms, plus 2a minus b. I used to have the scroll bar on the left. Trying out Cami, this is my first time, so I keep trying to go to the left to scroll. All right, so over here I have 5x minus 10. So I want to match these up is what I'm doing. So over here I have a 5 as a coefficient in front of x. Here I could rewrite this as a plus 2b times x. This is the same thing as saying a plus 2b times x, because multiplication is commutative. I'll finish writing that out. Plus 2a minus b. So here, in front of my x, my coefficient, is a plus 2b. So those match up together. So in the constants, we have 2a minus b would match up with your negative 10. So that's where we're going to get to our two equations. So again, we're matching up the coefficient of x with the coefficient of x and the constant with the constant. So here are my two equations now. So now I have in purple, I had a plus 2b must equal my coefficient of x on the left side, which is 5. And then I have 2a minus b. So my constants over here in pink have to equal negative 10 because those equations have to stay balanced. Now finally, I have two equations for my two variables a and b. So now I need to solve those. So you have two different options. You can still use substitution or elimination. It's up to you. Maybe for this one, we will do elimination. And let's eliminate our b's. So let me multiply the second equation here by positive 2 to get my b's to drop out. So that would give me a plus 2b equals 5 over now 2a minus 2b equals negative 20. We always add those together. So that those cancel, and we get 3a equals negative 15. So I can divide both sides by 3, and I get a equals negative 5. Now I need to find oh, you know what? I missed something here. 2 times 2 is 4. That should have been 4a, so this should have been 5a. Sorry about that. So that was 5a equals negative 15, so a equals negative 3. So now I have negative 3. Now I can find b by subbing in. So sub in to find b. So now I'm going to take the first equation, a plus 2b. So I'm going to sub in a negative 3 plus 2b equals 5. Add over my 3. Get 2b equals 8 and b equals 4. So now I have b is 4 and a is negative 3. So now I just need to write out my final answer. So we wanted to know how to break up or how to decompose the fraction of 5x minus 10 over 2x squared plus 3x minus 2. So that would equal, in our original up here, decomposition, so this could change depending on how you do your problem. You want to make sure, did you have A above the 2x minus 1 or did you have B? So that's really important how you defined it at the beginning of your problem. So I had A over 2x minus 1. So my A is negative 3, so it'd be negative 3 over 2x minus 1 plus 4 over x plus 2. Now you can also check that relatively quickly, not super quick though, by clearing out your fractions. So we already factored this over here. So again, if you clear out all of your fractions, we'd get 5x minus 10. The 2x minus 1 would cancel, so you'd have negative 3 times x plus 2 plus 4 times your 2x minus 1. So I just cleared out all my fractions, and I did all that in my head just now, so you might need to write that out. And then distribute into here to see if they combine. Or another way you could do it is just combining your fractions on the right side. So you could multiply this first fraction by x plus 2 over x plus 2, and you could multiply this second fraction by 2x minus 1 over 2x minus 1, and then add them that way. So then over here, it would be very similar to what I just had. It would just keep the denominator. I'd have negative 3x minus 6 if I distribute over 2x minus 1 times x plus 2, plus 4 times 2x would give me 8x minus 4 over the same denominator. And once you have common denominators, you can combine them. So negative 3 plus 8 would give us negative 5x minus 10 over 2x minus 1, x plus 2. Oh, that would be positive 5, negative 3 plus 8. So 5x minus 10, and that is the same as our left-hand side over here. So that is just for your check. But your answer is in the pink box. So a very long problem, as you can see. Let's do another one. So number 4, write the partial fraction decomposition of this fraction. So first thing we want to do is factor your denominator. So we're going to factor the denominator, which is x to the third plus 2x squared plus x. So the first thing I would do is factor out an x, leaving me with x squared plus 2x plus 1. And then I want to factor x squared plus 2x plus 1, which would be x plus 1 times x plus 1. Now, it is really important for this type of problem, though, to rewrite that as x. Since I have 2x plus 1s, you want to make sure you write it as x plus 1 squared. All right, so now I'm going to take this denominator and put it into my denominator. So replace the original. So 5x squared plus 20x plus 6 over x times x plus 1 quantity squared. That's going to now equal, let's keep it all in green here. And actually, what I'd like you guys to do is pause your video and set up your partial fraction decomposition. So this one, you should have 3 different fractions on. Go ahead and give it a try. All right, so the first one, you should have had x, then x plus 1, and then x plus 1 quantity squared. If you had done x plus 1 and then x plus 1 quantity squared and then x, that would also be fine. But again, that first initial setup, how you write it, is really important in the end when you're solving for A, B, and C. So here we have our A, our B, and our C. All right, so we've got 3 variables this time, A, B, and C, instead of just 2. So I need to solve this So again, we're going to clear out the fractions by multiplying through by your LCD over 1. So my whole LCD is always just going to be whatever it is over here. So our LCD is x times the quantity x plus 1 squared. So pause the video here, multiply everything through by your LCD over 1, cancel everything out, so all your fractions should cancel, and then write out your new equation. All right, so here you should have multiplied everything through by x times x plus 1 quantity squared over 1. This one we're going to do, I'll write it after every time, x times x plus 1 quantity squared over 1. This one, x times x plus 1 quantity squared over 1. And the last one by x plus 1 quantity squared over 1. Now I'm going to cancel out my terms. So here everything cancels. Everything should always cancel on the first one. Here just my x's cancel. Oh, thought I switched. That was in my way here. There we go. So the x's cancel there. X plus 1, one of them cancels, so we're still left with an x plus 1 up here. And here both x plus 1s are canceled. Do a quick check. Everything in the denominator is canceled out. So now let's write what we have left. So now I have 5x squared plus 20x plus 6 equals a times the quantity x plus 1 squared plus b times the quantity, or bx actually, times the quantity just x plus 1 plus c, and we have just an x left there. All right, so hopefully that matches up with what you got. Now I want to, again, my goal here is to match up the right-hand side with the left-hand side. So I want to find the coefficient of x squared, the coefficient of x, and what my constant is. To do that, we're going to have to expand everything over here and combine some like terms and see what we get. So pause the video and see if you can do some of that on your own. So you're going to want to FOIL some things out, distribute, go as far as you can, and then check back. All right, so here I have an x plus 1 quantity squared. So again, our goal on the right-hand side is really just to expand everything as much as possible. I'm going to write that out twice. Here I'm going to distribute in, so I get bx squared plus bx plus cx. I can FOIL out my x plus 1 quantity squared. So in there would be x squared plus 1x plus 1x would give me 2x plus 1 plus bx squared plus bx plus cx. And then again, I could distribute my a into my parentheses. So now I have ax squared plus 2ax plus a, and then I'm just bringing down the rest. So plus bx squared plus bx plus cx. All right, so again, we're trying to match it up to this 5x squared plus 20x plus 6. So what I want to do is I want to group anything that has an x squared together. So I'm going to rewrite those together. So ax squared plus bx squared. And sometimes the colors really help students to kind of match everything up. So I'm going to make those green. Next, I'm going to take anything that has an x. I'm going to put that in purple. So here's this. This has an x, and this has an x. So I'm going to write that next. So plus 2ax plus bx plus cx. And then let's grab another color. We'll do blue or red I chose. And really, it's just the A that's left after that one. Okay, so again, I know these are a lot of work, so really taking it step by step is really helpful. And I'm going to bring that down so I don't lose it here. So I will have over here 5x squared plus 20x plus 6. So I need to match up my coefficient of x squared. I need to find that because I know that's going to equal 5. I need to find my coefficient of x and make that equal to 20, and then my constant, which is 6. So to do that, I need to have only one x squared, only one x on my right-hand side. So to get there to be only one x squared, where now I have two of them, I'm going to factor out x squared from just the green terms. So here's x squared, leaving me with a plus b. I'm going to switch to purple. Now I'm going to factor out an x from just the purple terms. So I'm going to do plus x, leaving me with 2a plus b plus c. And then lastly, I have my plus a, which is my constant, and nothing else to combine or factor out there. So now I'm at a point where I can kind of group these up together. So here's my x squared. So 5 is the coefficient of x squared on the left-hand side. The coefficient of x squared on the right-hand side is a plus b. Remember, if you need to help you, you can rewrite this as a, let me write it below it, a plus b times x squared plus 2a, just commutative property, plus b plus c times x. I'm just switching the order right there. Oops, and then the last one, plus a. All right, so now let's match it up. So 5 is the coefficient of x squared. A plus b is my coefficient of x squared on the right-hand side. So I know that a plus b has to equal 5. Next, my coefficient of x is 20. Let me do a straight line. So my x is over here, so my coefficient of x is 2a plus b plus c. So that's my second equation. 2a plus b plus c has to equal 20 because that's the coefficient on the left-hand side. And then we have our 6, that one's our squiggle, has to equal our constant on the right-hand side, which is a. So a has to equal 6. Now having that a equals 6 is very, very helpful. Now I can set up and solve this system of equations. So now I have a 3-variable system, and it's not quite as hard as the other 3-variable systems that we've talked about recently because we already know what a is. So looking at these 3 equations, if I already know what a is right here, what else could I find? And hopefully you realize that you can find your b now. So if I take sub in a equals 6 into equation 1. So this is equation 1, equation 2, equation 3. So we can talk about them. So that's a plus b equals 5. So I'm going to put in a 6 for a and solve for b. So subtract 6 from both sides, leaving me with b equals -1. Now I have a and I have b. So I just need to find c. So now let's take equation 2. So sub in to equation 2. So 2 times a, which is 6, plus b, which is -1, plus c equals 20. So we get 12 minus 1 is 11. Subtract 11 from both sides, and we get 9. All right, so now we've done pretty much all the work. All we need to do, and don't forget this last part, is to write out your final answer. That's really important. Do not just find A, B, and C and then stop. I want to know what your actual answer is. You will not get full credit if you don't write this out. So our original was 5x squared plus 20x plus 6 over x to the third plus 2x squared plus x equals, so I had a over x. So a is 6, so that's going to be 6 over x plus b over x plus 1, so that's going to be -1 over x plus 1 plus c, which is 9, over x plus 1 quantity squared. Okay, and that is your final answer. Okay, and again, you can check this by getting common denominators here on the right-hand side and then adding them all up together, or even doing that clear out method again and seeing that the numerators end up equaling each other. So I'll let you guys do that part on your own to check. All right, I know these are challenging and they are long problems, so really take your time and work through them as you practice them and as you do your homework. So please let me know if you have any questions or need any clarification on any of these things. And I hope to see you guys soon, and have a great day, and pie out.